Let us study chemistry together with CBSE Chemistry tips and tricks.
Suggest the most important type of intermolecular attractive interaction in the following pair. First one is n-hexane and n-octane. The first thing you must know is n-hexane and n-octane are hydrocarbons. That all of you know, right? And hydrocarbons, you remember, they are non-polar. Okay. Now, if you understand the molecules are non-polar, then remember the force between them is London dispersion force. Remember this key point. See, for non-polar molecules like hydrocarbons, always think about London dispersion force. Okay, that is van der Waals force. You can either say London dispersion force as the answer or van der Waals force. Hope you understand. Next is I2 and CCl₄. Regarding I2, it is non-polar. What about CCl₄? You know CCl₄ have tetrahedral structure, right? And if you check each CCl bond, you can see that it have polar character. But due to its symmetrical tetrahedral structure, all dipole moments get cancelled. So what happened? CCl₄ as a whole become non-polar. Correct, right? Now I2, you already know it is what? Non-polar. And between two non-polar molecules, what is the type of interaction? Again, London dispersion force or van der Waals force. Hope you understand. Next one is NaClO₄ and water. Regarding NaClO₄, it is an ionic compound, right? It is an ionic compound. So what will happen? It will definitely dissociate to give Na plus and ClO₄ minus. So in the case of NaClO₄, you can see ions are developed, right? Ions are developed. Correct. Now what about water? If you check water, you can see due to high electronegativity of oxygen, see oxygen will have partial negative charge and hydrogen will have partial positive charge. And here you can see negative and positive charge are staying very close, act as a dipole. Water will act as a dipole. Okay, so here water is acting as a dipole and NaClO₄ is producing ions. Okay, so if ions are present, if dipole is there, then the type of interaction is ion-dipole interaction or ion-dipole force. Remember that. Remember this key tip. When one substance is ionic and other is polar, then the type of interaction is ion-dipole interaction. Next one is methanol and acetone. Regarding methanol, draw the structure first. What is that? CH₃OH. Next is acetone. What is acetone? Acetone is propanol, right? CH3, C double bond O, CH3. Correct? If you check methanol molecule, you can see that hydrogen is attached to a highly electronegative oxygen. So what will happen to this electron cloud? It will shift towards the oxygen, right? It will shift towards the oxygen, making oxygen partially negative and hydrogen partially positive. Correct, right? So you can see partially negative charge and partially positive charge on adjacent atoms, making it polar. So it can act as a dipole. Correct, right? Okay, now what about acetone? Here you can see this oxygen, right? Highly electronegative, is connected to carbon, making it partially negative. Carbon become partially positive. So it can also act as what? Dipole. Correct? It can also act as dipole. So definitely between methanol and acetone, dipole-dipole interaction is there. Along with that, definitely there will be a hydrogen bond established between, see this particular hydrogen of methanol and this particular oxygen of acetone. So you can say hydrogen bond is there, dipole-dipole interaction is there. Correct, right? See, the first methanol, right? Methanol is a dipole. This is also a dipole. Between dipole-dipole, there is dipole-dipole interaction. That's the first thing. Along with that, you can see strong hydrogen bond will be there, right? Correct. So both are there. Remember this as a key tip. If either molecule contain OH, NH or FH. See here you have OH on methanol, right? And another molecule has electronegative atom like O, N or F. Acetone have O, right? With lone pairs. Then think about hydrogen bonding. Definitely we already understand that what hydrogen bond exists between methanol and acetone, right? Okay, it's a key tip. Okay, you keep that point in your mind. Next one is acetonitrile and acetone, right? What is acetonitrile? See, this is a structure, right? And you already know what is acetone, this one. Now, if you check this particular bond, nitrogen, you know, comparing with carbon, it is highly electronegative. So, carbon become positive, nitrogen become partially negative. It will act as a dipole. Same thing, right? Oxygen is highly electronegative. It become partially negative. Carbon become partially positive. It also act as a dipole. So two dipoles interacting, we call it as dipole-dipole interaction. The type of interaction between two dipoles are what? Dipole-dipole interaction. Here acetonitrile act as a dipole, acetone act as a dipole. So the type of interaction between them is dipole-dipole interaction. Hope you understand. So these are the final answers. Okay, go through this.